Last thing we're going to look at with the trig is how to use it when we encounter certain problems, real life problems. And one of the things that a lot of trig problems involve are something called angles of elevation and depression. When you stand and you look at something, you can draw, like if you're not lifting your eyes up or lowering your eyes, you're looking straight ahead. So we call that a horizontal if you're looking straight ahead. As soon as you shift your eyes up to start looking at something above, that is an angle of elevation. Okay? Remember, an angle is formed between two arms. So you start looking straight ahead, the horizontal. As soon as you look up, an angle of elevation is formed. If you start at the horizontal and you look down, an angle of depression is formed. So we need to know the difference between those two whenever we encounter a problem that involves trigonometry. And one other thing about angles of elevation and depression. So, you right there, Beatrice? Okay. If I'm standing up here, and if I'm looking straight ahead, and I decide to look down to Makeda, there's an angle of depression. That's the same angle of elevation that she's looking up at me. So from her position, she has a horizontal, and she has an angle looking up at me. That's the same angle. So if we're looking up at something, or so let's say it doesn't have to be an object, it could be a person. That's the same as that object or person up there looking down at us. So those two angles would be the same. Just like if we're looking down at something or someone, on the bottom, if we draw a horizontal from that person or object, it's the same angle as them looking up at us. And we can use that to help us solve trig problems. Do you have it? Okay. All right, so let's look at some examples where angle of depression and angle of elevation are involved. And some good advice on these types of problems, it's always good to draw it out using a diagram. Because your diagram should form some sort of right triangle. And then that will help you figure out what numbers are what and what kind of trig I need to use to solve the problem. So in this problem, we've got a point on the ground that's 15 meters from the base of the Richardson building. So we've got the Richardson building, we've got the ground, and then there's a point here, and it's 15 meters away. The angle of elevation to the top of the building is 80 degrees. So the angle of elevation, remember, one of the arms is always horizontal. Well, from this point, the horizontal is the ground. So that's one arm. The other arm is the line of sight or looking up at the top of the Richardson building. So this is the angle of elevation. And in this case, it's 80 degrees. And we're asked to find the height of the building. Well, so our unknown is here. So there's a diagram of our situation. We can see where the right triangle is. It's right here. And basically, we're trying to find this side. Well, using our trig, if this is the angle we're dealing with, this is the opposite side. This is the hypotenuse. So this is the opposite side. This is the hypotenuse. And this is the adjacent. Well, I'm trying to find opposite, and I'm given adjacent. So opposite and adjacent mean I have to use tan. So to set up my equation, the tan of the angle, in this case it's 80 degrees, will equal the opposite side length h over the adjacent side length 15. Now, once you've got it set up, it just comes down to algebra to solve it. I want to get h by itself, let's do. So I times both sides by 15. Times 15, divide 15, cancel each other out here. So to find h, I need to do 15 times the tan of 80 degrees. And that's when I pull out my calculator. So 15 times tan 80 degrees will give me, to the nearest whole number, approximately 85 meters. So we're using trig, but we have to set up the problem to figure out what trig to use. So that would be an angle of elevation problem. Second example, we've got an angle of depression problem. We've got an aircraft carrier, or sorry, an airplane that has to land on an aircraft carrier in the middle of the ocean. In order for the pilot to see the aircraft carrier, he must look down with an angle of depression of 35 degrees. If the airplane is 2,000 feet above the water, how far the horizontal distance is the plane from the carrier? So we need to do a little drawing. And your drawings, I'm sure, will probably be better than mine. So we need to draw a plane. And we need to draw an aircraft carrier. And then we've got the water. So the angle of depression from the plane to the carrier is 35 degrees. So to draw an angle of depression from the plane, first thing I need to do is always draw a horizontal. And then draw a line of sight from the plane to the carrier. That angle between those two lines that I just drew, that is the angle of depression. So this is 35 degrees. We're also told the height of the plane is 2,000 feet. It should actually say 2,000 feet above the aircraft carrier. So the height of the plane, where can we draw this height to make a right triangle? We can draw it here. That's the height. That's 2,000 feet. And the reason I drew it there is because now I've got a right triangle that I can use to answer the question. And what is it that I want to find? The horizontal distance, not the slanted distance, the horizontal distance. So that's the unknown. Can somebody tell me what my trig equation would look like? What trig am I going to use? Here's the angle. What's the name of this side in relation to this angle? Opposite. This side, adjacent, which means tan. So the tan of the angle, 35 degrees, is going to be the opposite side, 2,000, over the adjacent side, D, which is what I'm trying to find. And now we're ready to solve our equation. So I want to get D by itself. Well, the first thing I'm going to do is get rid of the fraction by multiplying both sides by D, because the D's cancel out on the right. And I'm left with D times tan 35 degrees is equal to 2,000. And then to get D by itself, I divide by tan 35 to get rid of that, which means I have to divide this side by tan 35. So to find D on my calculator, I have to do 2,000 divided by the tan of 35. So 2,000 divide tan 35 to the nearest foot will give me approximately 2,856 feet. Okay, so there's problems that involve angles of elevation and depression, but with one triangle. Sometimes we will encounter problems where there's more than one right triangle. And we're going to have to use trig a couple of times to find the answer we're looking for. Here is one such example. From the top of a 25-meter lighthouse, the angle of depression, actually this should say to a boat, not of a boat, to a boat is 9 degrees. 1 minute later, the angle of depression of this boat to this angle of depression to this boat is 14 degrees. How fast is the boat traveling? Assume that the boat is traveling towards the lighthouse. So again, we have to draw a diagram of this situation. So let's get our lighthouse. Here's our little lighthouse. And then out on the water, we've got a boat where it's here at one point, and then as it's traveling towards shore, it's here at a different point. We need to find out, in order to find its speed, how long it took to get from here to here. So we're actually going to create two triangles, two right triangles. One is going to be to the far boat. So remember, the angle of depression, you draw a horizontal out from the lighthouse, and then you draw a line of sight from the lighthouse to the first boat. That is 9 degrees. The lighthouse is 25 meters high. So this point here, or this segment here, is also 25 meters high. So I just created a right triangle, the red one. Like so. Okay. So remember what I'm trying to find. I'm trying to find the distance from where the boat started to where the boat was a certain time later. And I know that at a certain time later, from the lighthouse, if I look again, this time to when the boat's closer, the angle of depression is 14 degrees. I know it's a little bit of a tricky diagram, but I've created another right triangle. This is 25 meters. So I've got a green one, I'll label it. And remember, the 14 degrees is with the green one. The 9 degrees is with the red one. Well, this again, this is what I want to find. I want to find this here, which I'll call D, which is the same as up here. This is D. How would I find it using the two triangles? Well, couldn't I find the length of the long red one here using trig? And then the length of the shorter green one here using trig. And then when I subtract those two, I get this. So I'm going to call the long one D1. That's the one that goes here. And I'm going to call the green one D2, the shorter one. So I find D1 and D2, and then I subtract them to find my answer. Okay, so yeah, it's important to draw a good diagram. Don't, if you're drawing it, don't make it too small, because then it gets really hard to read. Okay, so the long red one, D1. So that's 9 degree and the 25 meters. So the 25 meter side is opposite 9 degrees. D1 is adjacent, so which means I'm going to use tan to find D1. And the tan of 9 degrees is equal to 25 over D1. Similarly, For the green triangle, I'm going to do the tan of 14 degrees equals 25 over D2. That's how I'm going to find D2. So now we just got to use algebra to solve each one. And then subtract the 2 to get our final answer. So to solve this first one, I'm going to multiply both sides by D1 to cancel out the D1s, which means I got to multiply the left-hand side by D1. So I get D1 times the tan of 9 degrees is equal to 25. I need D1 by itself, so I got to get rid of the times tan 9 degrees by dividing tan 9 degrees. And whatever you do to one side, you do the same thing to the other. So to find D1, I'm going to do 25 divided by the tan of 9 degrees. And I'm just going to go to the nearest, what is it, meter? Is that what we're in here? Yeah, 25 meters. So 25 divide tan 9 will give me approximately 158 meters. So when this whole situation first started, the boat was 158 meters out. D2 is going to tell me how the distance, how far the boat was out 1 minute later. So I solve it pretty much the same way that I solved the first one, times both sides by D2. So I get D2 times the tan of 14 degrees is equal to 25. To get D2 by itself, I divide both sides by tan 14 degrees. And therefore, D2 will equal 25 divide tan 14. 25 divide tan 14 is equal to about 100 meters. So, how fast did the boat travel in that 1 minute? Well, we just have to subtract. So to find the distance, it's 158 minus 100. Which means it went 58 meters in 1 minute. Or that's its speed, 58 meters per minute. Just make sure that's right. Yep. I'd like to do one more similar to this, just so you can get the hang of it. And this one involves a tower, a ranger tower, somewhere in the bush, 100 meters tall, and a ranger observes two fires, one at an angle of depression of 5 degrees, one at an angle of depression of 2 degrees. Okay? Which one's further out? The 5-degree one or the 2-degree one? Which one would be further out? The 2-degree one, which is pretty small, or the 5-degree one, which is a little bigger? The 2-degree one would be, right? The smaller the angle of depression, the further out something is. The bigger it is, the closer it is. Okay, so let's draw this situation much like we did the other one. So let's draw fire tower. And then off in the distance we have, and they're on the same side, we have two fires. The closer one has an angle of depression of 2 degrees. The further one has an angle of depression of, the closer one has an angle of depression of 5 degrees. The further one has an angle of depression of 2 degrees. So now we've got to draw right triangles. So from the tower, to draw an angle of depression, first of all, draw a horizontal. We'll draw the further one first, the fire that's out further first. Draw a line of sight from where you drew the horizontal to the furthest fire. That angle of depression is 2 degrees. Remember, the tower is 100 meters tall. So this is 100 meters, and so is this way out here. This imaginary segment is 100 meters as well. There's my right triangle, the red one I'm going to draw. Now I draw a similar right triangle. I'll just use a different color. So green, from the tower, there's a new angle of depression from the horizontal, and when I'm looking down at the closer fire, that's 5 degrees. And to finish the triangle with the closer fire, I just go from the closer fire up until I hit the horizontal. Now I've got a second one. This is very similar to the previous example we just did. And remember, this is still 100 meters. So to find how far apart the two towers are, or the two fires are, we find the horizontal distance to the furthest fire, which is in the red right triangle, which is D1. Then we find the horizontal distance to the closer fire, which is the green right triangle, which is D2. And then when we subtract those two, we're going to get the distance between the two fires, which is what we're asked to do in the first place. So we need to do some work now, some trig and some algebra. So looking at the red right triangle, we've got a 2-degree angle. The opposite is 100. The adjacent is D1. So the tan of 2 degrees is equal to opposite 100 over adjacent D1. For the green one, this time it's a 5-degree angle. So the tan of 5 degrees is equal to the opposite side 100 over the adjacent side, which we've called D2. And now we solve each one. So for this one, we multiply both sides by D1. So we get D1 times tan 2 degrees equals 100. Divide both sides by tan 2 to get D1 by itself. And therefore, D1 will equal 100 divided by the tan of 2. Which is 2,864 feet. We solve for D2 in a similar fashion. Multiply both sides by D2 to get rid of the fraction on the right. So we're left with d2 times the tan of 5 degrees is equal to 100. To get d2 by itself, we divide both sides by tan 5 degrees. Therefore, d2 will equal 100 divided by tan 5. (1,143). d2 is approximately 1,143. Sorry, this is not feet, this is meters. I need to change that in the red one. I was thinking of a previous question. So what's the distance between the two? Just subtract. I'm just going to block this off here. So to find the distance, I just have to do the distance out to the furthest fire minus the distance out to the closest fire. And that will give me my final answer of 1,721 meters. Finally, we got there. Okay, one more question. And we actually don't have to do a lot of work for this one. Just have to think about it. What if the two fires were on opposite sides? How would you find the distance between them? If they were on, like here, to start with, they were on the same side, so we subtracted, right? What if they're on opposite sides? What would we do with the two distances? Add them. So all you have to do for this is add the two distances you found in A. 2,864 plus 1,143 will give you an answer of 4,007 meters. Okay.